Further study, started to turn out that there is a way your cells talk to themselves and monitor their activity that was literally earth-shattering, that was being sort of uncovered about the same time, where a group of scientists won the 1998 Nobel Prize in Medicine for the discovery of a single molecule that your body makes that didn't have carbon in it. And that molecule was used to signal something very important. So what we'd never heard of, imagined, or seen before was a non-carbon molecule making signals. It was called nitric oxide, two most common atoms in air. Real small, real simple, but its first discovered activity was that it would cause, if you gave it to people, it would cause the blood vessels that supply the muscles of the heart to open up, called vasodilator. So it's really important in pediatric cardiology, and then later on in adult cardiology, won the Nobel Prize for that. And then later on it became the active ingredient in Viagra, then got famous. So this science opened a door that we didn't know was there. And we began to look at this fascinating material that was created actually by accident, messing around with salt water. And they created the ability for the cells to clear up and ramp up their internal communication significantly with certain sets of these molecules that didn't contain carbon. Now that has grown so that since 2000, there are 17 medical societies, over 18,000 books, and a massive 5,000 to 10,000 attendee conference in Paris every year for this new idea. It's not a new idea. So God said, look, there's not a cell on the planet that can survive without this. And the idea was this. We found out about DNA and how it was built in 1969 by two guys named Watson and Crick. And they figured out how it was all put together, and how that DNA splits in half, makes new proteins that make the materials that make all your organs and your whole body and the whole deal. So for years they thought that that was the determinant in what you turn out to be. It'll do things like what's your eye color, how tall are you, what are your male or female, those kinds of things are dictated. But whenever you get damage, the cells have to be replaced. And normally, every single cell in your body is replaced in less than 7 years. We started following some of this stuff, and we found out that the killing agent that killed the bad bacteria and left the good bacteria alone was made in the process of cells making their own energy. And something most people don't know is that every cell, whether it's a single-celled animal, a plant, or a person, or an animal, all have to have factories within the cell to make their own energy. Now, those factories are fascinating. We've studied them a bunch, especially of the athletic side, the medical side. If you were to, anybody here take any advanced science in college, biological science? You ever hear of the Krebs cycle?
Oh, yeah.
Well, in that Krebs, oh yeah, we had to study that thing. We had to draw it all out on that piece of paper. And in that cycle, what's happening is you're taking the food that goes in the form, two different forms predominantly. One of them is fatty acids, and the other one is sugar. And the sugar is a 6-carbon sugar, and it goes through a cycle. In the cycle, that begins to start to pull off a carbon, leaving a 5-carbon sugar. But when it pulls it off, it steals a little of the energy, and that puts into these little batteries called ATP, and that runs everything. And each of those steps along the way, in about an 18-step process, creates the energy that makes a cell live. All of them have to do it. Even plants have to do it. Even microbes have to do it. So that was fascinating. Everybody kind of knew about that. But now we know something much broader in God's creation. Just really cool. This began to answer so many questions we couldn't answer. One was, when you're in the embryo, you are an embryo, you're in the embryonic state, you can build every organ without affecting, well, you can build every organ basically from nothing. One cell becomes two, two become four, four become eight. We didn't know when this first cell splits and there are two here that are exactly the same place, in the same time, in the same location, with the same DNA. There's nothing variable that would indicate why this one starts to become arms and legs and this one becomes lungs and feet. The cardiovascular system, the nervous system. We didn't know how that happened when they were there. They have to be internal communicators within the cell. We also found out, and this was something from my own research that was just fascinating to me, was I was teaching pediatric neurology, the developmental stuff that John was going through, to a bunch of orthopedic surgeons at the Shriners Hospital that were used to working on adults. They were going to go back to working on kids. So they were making them learn developmental stuff. When do things start? How do they start? How does this nervous system kind of kickstart and work? What does it use? And as I was describing it to this class of surgeons, they were going through a lot of basic science as a review. And I said, because of this fascinating nervous system that we have, that's been really studied a lot, we can take in information and process it. You don't fall over the chair when you're walking out of the room. You can stand up, it starts to wobble a little bit, you can adjust to it. You can go outside and it's colder than heck, so you go in and put on a coat. You adapt to your changing world through your nervous system. Somebody gives you a kiss on the cheek and you turn red. You know, so it's all this stuff is interconnected. And we said, because we have 5 senses, anybody know what they are?
Sight, touch, taste, smell, hearing.
And hearing. You got it.
Count with that last one.
Now, all of those I was describing to the class have sensors, and those sensors will send the information along these series of connected cells, but then they have to go to other connected cells to figure out what the story is, where it come from, how fast were we moving, what angle were we going, what's that in our experience. And it has to do all this checks and balance in your brain. And it was doing things, but when I was in my laboratory, I began to find that the reflexes that little babies have. Anybody know the Babinski reflex?
Oh my goodness. That's the reflex that John had, and that's how they discovered it was way up in his spine. That was like the big like red flag. So
do you remember how they did the test?
They scraped the bottom of his foot, and
so you've done the test before?
A long time ago.
On your kids?
No, I'm a nurse.
Okay, so this Babinski reflex is one that we all have these reflexes. Which some of them you want them. You know, stick your hand in hot water and you pull it out real quick. But it takes a moment for you to go, whoa, what was that?
What is that? Yeah.
Wow! That processing time is when it starts making all these connections and figuring out where was it, what in our experience was that, what do I do? And we were at a loss because there were things we could do with reflexes that were faster than all of that. Well, it turns out the reflexes are set up so that the response from the Babinski reflex goes to the spinal cord.
What is that one?
It's what?
What is it?
It's where you like take your finger up the baby's foot and it'll pull back up.
Okay.
You do one on their belly button. Another one that's really weird is if you turn their head when they have very low function. You turn their head like this and their other arm will go out. And then they roll their head this way and the other arm goes out. And so we think that in the development of movement in the womb, they're designed so these accidental things will happen. And when the accidental thing happens, your brain goes, hey, I've seen that before, and it'll start to do what's called build more high-level connections, and we call it override the reflex. So you could do things on purpose by your direction, not just reacting to the environment. So got into all this discussion, and I was talking with these guys, and I said, because of all of that nervous system where it goes along this series of interconnected cells, we can move away from noxious stimuli. We can ingest, digest, motivate, procreate, move toward positive stimuli. We could find food. We could fight our own battles. We could make decisions. The guy raised his hand in the front row, and he goes, "Hey, Prof, we just came from a class where we put a little drop of water on a slide, and he said there's a cool little single-celled animal in there called paramecium. You ever seen them? I should get a picture of them. They look like Casper the Ghost. They got these little ear things sticking outside. They're just clear and they're friendly looking and all that. But you can watch all these things happen." And he said, the weirdest thing, when you said those, he said, we had actually stuck a hot probe in the water, and this single-celled guy goes, that ain't good, and turned around and went the other way. So he said, then we saw it find food, ingest food, because he was crystal clear. You could see him digest the food, eliminate it. And then one over here was creating a new cell by splitting in half, a new animal. So he says, if it takes a nervous system to do all those things you mentioned, and that nervous system is a series of interconnected cells, what's the nervous system for a cell? How does it adapt to its world? Because you don't have a bunch of connected cells. So I said, that's a different class. We'll get to it later. In other words, we had no idea.
Yeah.
Along came a few ideas from this technology that began to answer the questions of how does a cell know what to call upon, which parts to build, which departments to talk to, tell this guy to knock it off, how to send out a message to other cells to correct it if there's no nervous system. We've now discovered the active nervous system in the cell. It's very simple, very easy to use, and you can all feel it here in less than 1/100th of a second if you want to. Wouldn't it be interesting is before birth, while you're still breathing out of your belly button, you can build body parts, but immediately after you're born, you can't start from scratch and build a new one. What happened? DNA is exactly the same as the original cell that started you. We're just losing the ability to read it at certain stages along the course of your life. And we began to find out that the factories that make energy, those ones that burn through that cycle I told you about, you start losing them as you get older. And with the loss of them, you lose certain key letters of the alphabet that make you react and heal faster, better, to make enzymes for digestion, to create new cells to replace old cells. All these things require information. Well, we now know that you start losing that information, and then you start to kind of fall prey to lifestyle stress and environment. So 85% of all disorders that are in the medical profession today are lifestyle stress and environmental problems. Which means, well, then there's 10% that are mental and anxiety and stress. So it's basically 95% are all then things you didn't have when you were little that you got when you were older, or you had more difficulty overcoming. Things like, see that little guy right there? If that guy broke his toe, my grandson broke his toe at 2 years old. Now, let's say Jessica breaks her toe. How long would they put her in a boot?
6 weeks.
Forever, yeah.
It'd be about 6 weeks. She's just between 6 and 8 weeks. For me, at 70 years old, it's typically going to be 8 to 10 weeks.
I thought you were about to say 70 weeks. I was like, that was way too long.
And the younger you get, the faster it gets. So my grandson, it was 2 weeks. Same cells, they have the same DNA later on in life, but they don't turn over as fast. So we started studying skin, and we found out if you take a baby, they make brand new skin every 14 days. Every single cell in their skin is replaced. And they feel amazing, right?
Yeah.
And then they go,
They're soft.
what's the baby's name?
This is Leo.
Leo, can you teach us how to do it?
Wise guy.
Then we found out that at the age of 20, you start making skin at half the pace. So it's 28 days instead of 14. Now what that led to was a series. I'm going to show you a couple of quick pictures of this. So you don't think I'm fooling you.
You trickster.
It's been said before. Hey, it works, okay. So, let's take a look at this little girl here. She's got a condition that's growing on her face, pretty problematic, and on her arm. Now this, she could probably fix with antibiotics, but she's allergic to antibiotics, has an anaphylactic reaction, and she couldn't tolerate it. So her family was very concerned and started wondering, why is it that this here continues to grow outward, and here, she lives in Manila, Philippines, and so it's warm. But this up here isn't affected, or this over here isn't affected, because it has a natural prevention system that works in conjunction with its neighbors. And when the neighbors start to fall apart because they got infected, then it makes it more likely that the ones surrounded by it will get it fall apart, not have support. So the first thing I want to show you here is that because of this, they could not give her an antibiotic. So what are you going to do? So we took this gel that literally puts the letters back in the alphabet that allows the system to start remembering how it used to work when you were young. And it started recognizing things more quickly. This is 4 days later. So this indicates two things. One is how fast the kids will fix themselves with that fast turnover of skin. But under age 2, which is really interesting, is that they don't form a scar. They don't need to. It'll close up so fast if you make a cut that it'll literally close while you're sitting in the room. And so they don't have to worry about the infections as much as somebody who's over the age of 2. By the time you're 3 and 4 years old, you'll start forming a scar because it takes longer, and you don't have this thing called tendrils that reach across and pull and close. Things change. So this little one didn't form any scars, but here's one from down the valley. He cracked his head when he was sledding. I like to use things that you can see. Everybody can see the wound on his head. Now this thing's going to get stitched up, and it's typically in a 2-year-old or under, they'll close that wound, and you almost can't pull it apart within hours. But it's going to take as many as 11 days for this wound in an older kid like this. So they stitch it up so it doesn't move. And those edges are looking for each other and trying to come together. We've now found this gel that we can put on, or a spray, completely innocuous. It's something that your body already makes. You're just rebooting it, putting some back in. So the family did that. It's it's an antibiotic, antiviral. It's all kinds of good stuff, and it can't hurt anything. So it's part of what your body already makes anyway. Well, the surprising thing was the family friend lives across the prairie by me. He's an ER doc, and he goes, "Hey, wait, something weird's happening here. You've had those stitches in for too long." Now, most people don't know what that means, but this dot right here, who's ever had a family member with a pierced ear?
Yeah.
Or you have done it yourself. You know, they go through a period of time where they keep the post in there, and what is the post doing? It's helping to keep it open so it'll grow a skin tube through there. Otherwise, you would be getting infected and getting stuff inside your body all the time. You want the skin to grow through the tube, and that's what's happening here. Is if you don't take the things out in time, it starts making these tubes that will take dirt under your skin, and that would be a problem. So we got to get this thing out. So he goes, "Okay, I'm getting my suture kit." And he takes out this thing. He's expecting that it's 13 days since the injury. But because we put this on, he asked the family when did he do it, and they said day before yesterday. So this is the second day instead of the 13th. And what was happening? It was starting to remember how it used to work when he was a little kid. And so instead, where we typically would see this form a scab and then a scar, and then that scar would remain for a lifetime, right? In this case, it went from that to this in 6 days with no scar.
That's just unheard of.
Yeah.
So this goes simply back to what you used to do. Can anybody see some exciting potential for this if it's every cell? Heart, brain, blood, eyes, bones. If they just simply remember what they used to do, it's not like you have to reboot the whole system. You have to add something weird. You're just filling up the cup and doing what's normal. I'm going to just fly through a few of these, but this is another example of skin who gets older and older and older. In this case here, and in this case here, the skin is lasting too long. Up here, probably we're guessing about 85 days the skin cells are lasting. Now when you're 20, it's only 28 days. So it's long past its capacity to keep hydration and elasticity and fight its own battles. And this is a 69-year-old physician, and she's just losing muscle turgor, we call it, and the skin's bagging. This is 30 days later, simply remembering what she used to do, and we see about 16% faster cell turnover. Why? Because she always used to do that anyway. And we begin to start to see the same thing here. All kinds of we really dissect this out, look at the difference in the chin here and the chin here. Has anybody known someone who would pay to have that done and it's surgical? It's really dramatic. In this particular case, it just reminds the skin to do what it used to do. These three spots here are the age spots, and that just means you're not getting enough circulation to take away the waste products. And so we've now got the ability to change those dramatically. This is an interesting story up here because she's got hyperreactivity you see it in a lot of teenagers, and this is not a very friendly thing for your kids to have. I mean, you just really don't want to see them get this kind of stuff. They said, well, we've got a material that we can use called Accutane, a drug.
Hard on you. Yeah.
And they said, in your particular metabolism, you have a choice. Yes, we can take your skin and make it better, or you can have babies. Because she would become sterile. On the other hand, when she was 7, her skin didn't like it. At 17, her skin was acting differently than it did at 7. This is 4 days later.
Accutane doesn't make you sterile.
Only this particular girl who was missing some enzymes.
Because
And genetic.
I work in dermatology.
Oh, okay. And she had 2 or 3 different enzymes and a protein that she wasn't making normally, and that Accutane had a specific reaction with those that would cause her to lose her fertility. The net is, everybody's different, but in her case, she needed a different option.
But how would they know she had those proteins and that Accutane would?
Because she was a genetic. Have you heard of some of these 2-name syndromes where there's only 5 in the world and the family knows more about it than the doctors do. And they mentioned that, you know, she's got this syndrome above and beyond just cystic acne. So, so in that particular case, it was just a really rare occasion. But again, another kid who's just, you know, wishing for the ability for those cells to improve. Here's an 84-year-old, and we can see that the skin is long past its ability to really keep up. And just simply applying a topical application, by the time she's 87, by the time she's 92, she still looks amazing. I didn't have the extra picture, but this is really nothing more than saying, will these reproduce? The same thing with creping. You didn't used to do it. If you can remind your system to change, that's what we see. This is a lady who's having chemical peels. From a dermatologic standpoint, what are chemical peels generally used for?
Well, they resurface. They basically take off the top layer of your skin.
And what you're doing then is you're saying, we're going to force them to have to make skin faster, because if the cells last too long, some people grow tumors and all kinds of stuff. It's a pretty nasty procedure, and she didn't like having it done a lot, but she was able to stop having it done. This is a guy who's a real interesting case because he was having a chemical peel too, but this is 7 months later. He's old enough at 95 years old, he's forgotten how to fix it. This is 5 days later. So 7 months and 5 days. And we're standing back going, this is nuts. In fact, this is going to be some of my favorite right here. This scar, we didn't really think this was going to happen, but that scar is made of cells just like the skin is made of cells, and the cells have to replicate, and they still replicate about the same speed. And once you get the scar, it's just going to keep making scar. And when we started working on burns, we thought, why? If it has to read the same DNA that hasn't changed from the time of inception, and it does it every so often, why doesn't it read it fully and go, okay, we're done with the use of a scar. It says on the blueprint here, make skin. Why doesn't it go back to that? So we wondered, and then this lady comes along and she gets this scar, and they've been there for 17 years. At the rate her skin turns over, that means 144 times. You've got a pattern set. It's going to probably make scar the next time it changes, right? This is 30 days later. Reading the original DNA in the original way. Wouldn't that be interesting? Then we see this. Is there a market for this?
Just going to moms.
So this is the lowest level. I mean, you're down 12 layers deep in the skin right here, where the cells are being produced, and if they're producing scar, wouldn't it be interesting if we could change that? This is a little family friend. No, that's not. Just another one of those. This one here. This is a little kid who poured hot water on his foot just 45 minutes later at the doctor's office, and the one on the right. And pretty well messed up. So they're planning to do the debridement and take things off and get to a point where we're going to see how much we have to replace and graft. And so we instructed the family to use a little spray bottle with this in it. And we know that the antibacterial, antiviral is important, but when you put water on it, the cooling effect from evaporation is 17 times faster than if you were to hold a cold compress on it. So we want the cooling effect. That's a big deal. But the secondary thing surprised us, because we learned from this little baby here, because we can see a lot of, and some of you might be able to experience a reduction in pain while you're sitting here. Let's see. We can't say pain. No, you have to. This is not a drug, so you can't. It fell now into a category called a supplement instead of a drug. It's actually a bio-replenishment. But with that, there's a requirement that anything that is taken by mouth that is not a drug, you must say, It can't diagnose or treat or cure or heal or prevent anything. But what if, in the presence of the right information, the body can remember how to heal itself? That's a process. So, in this little girl, she stuck her hand on a halogen light at 18 months old, and the neighbor was a new nurse and thought it'd be a good idea to cut a lot of the skin away. Now, this is problematic and very uncomfortable. So we took this and poured it in a plate. The baby put her hand in the plate and in a couple minutes stopped crying. Wrapped it up, she could play for several hours. Surprising to us, and I wish this was a clear picture, but what happened after this, where we're trying to figure out some kind of strategy, in 26 days she regrew the entire hand with every crease and every fingerprint as if it was rebuilt in the womb. So we thought, wow, it doesn't hurt, let's try it again. So we tried that with this little guy. He was scheduled to go 7 weeks of each week progressively taking more of the skin off and then starting the skin grafting process. So we had him spray it on it and feel better, wrap it up. On the 11th day when they went in for the first debridement, this is what the doctors found. Now that ribbing is just from the sock he was wearing. So we thought this would only happen in little babies. But this guy stuck his leg on the tailpipe of a motorcycle at 50 years old. Now this is a deeper tissue problem than just the skin. And this is going to get a real thin, tight, crackly scar, and it's going to shrink and tear and do all that sort of stuff. But once we kind of re-suggest it back to the system, because he's using it to stop bleeding and to keep the discomfort down. But to our amazement, this is 13 days later. Didn't form a scar at all, but rebuilt the other tissues. Now we do have one of the people, but this is just a gathering of people. Once it came out in this form, and they said, we can't make it into a drug because you can't harm anything with it. Just have people share it with people. Don't imply that it'll do anything, but people share it with people. And one of the families is a guy down in, the wife is a triple boarded physician. She's a thoracic surgeon, and she does geriatrics and anesthesiology. Her husband was a pediatric researcher and had lung removals from something he picked up over in Desert Storm. He had to be on oxygen to watch TV, and he was a marathon runner prior to that. So he gets around this stuff, and his body starts to operate a better, more efficient way. So he's off oxygen, he can fly on a plane, he can do all kinds of stuff now. And he started using it, and in Scientific American, anybody ever hear of that magazine? He has the cover article from a couple of years ago, was the first person to grow a lung outside the human body. And it literally went up to the space station, and they're rebuilding organs from your own tissues on this matrix under these guidelines, and in watching the cells figure out how to do what cells do. His name is Joaquin. This is a condition where the skin is actually an autoimmune. If you're in dermatology, there's probably a handful of autoimmune responses, right?
Oh yeah.
And all kinds of different ones. Now this one, they were using steroids and gloves, like a gooey, gummy stuff, and then they put the gloves on for 6.5 years. And this is the best result. What we know is that when the immune system was sending out the white blood cells, like Darth Vader with a lightsaber, says, what's causing the inflammation? I'm here to take out any bad guys, right? And the weird part was that the immune system could find the bad guys, but leave the good guys alone. The cells all have a recognizable signal. It's like a neon sign. It's got letters, and it has to have enough energy to be recognized. And so here comes Darth Vader. I'm going to take out the bad guys, and recognizes this cell says friend on the side. Sorry, man. Oh, you're inflamed. I don't. But when you have an autoimmune problem, it's like the letter R fell off, and it says fiend. So it goes after it. Once you damage the cell and it's inflamed, then the immune system responds to the inflammation, attacks the cell, it causes more inflammation, and you start a cycle. She's on that cycle. This was a month after taking this orally, and then I think came up with a gel at that time too, but originally all there was the oral. This is another condition that's happens. And I show pictures of the skin primarily because it's gooey underneath and hard to get pictures. But it's happening with all kinds of cells in all kinds of places. This one's another one where the immune system's attacking normal cells and then recognizes, oh, sorry, dude, didn't want to mess you up. Yeah.
Yeah, that was going to be my question actually. Is it effective on not only on, you know, on the outside of the body, but is it, you know, if you have a sore throat or a stomach ache or a
Everything that a cell in your body has to do, what parts are made of cells?
everything, I think.
How about bones?
Yeah.
How about
Eyeballs?
liver, kidney?
Yeah.
What about hormones?
Hormones are produced by the cells as part of the signaling process we were talking about,
Right.
but they contain carbon. And we knew that there were some saccharides, like sugars, that contain carbon, that could signal things to the body. This is now a whole class of things that don't have carbon, but hormones, if your hormones change, all of you have experienced that at least once in your life. And when those hormones change, so do, like, let's say, for example, did you know before puberty, your cells burn predominantly fats first and sugars later. After puberty, they start burning sugars first and fats later. That partly explains why a little kid, try following 2 7-year-olds around all day and try keeping up with them. Now, the part that's interesting in athletics, where I do a lot of research, if you take little kids and you put them on 2 practices a day in some sport, they can play all day, then they go home, fall out of a tree, wrestle with the dog, and they go to bed, and no one's ever sore the next day.
Yeah.
You ever notice that? Isn't that crazy? But if you're a teenager and you now have the hormone change and we put you to 2 practices a day, you're so sore you can't get up out of the basement. The reason is you're burning all these sugars first, and you're burning them fast, and they leave lactic acid. But if you burn the fats, they have 60 times more energy density than a sugar molecule. So you got more energy, and it burns all the way through the Krebs cycle, comes out with carbon dioxide and water instead of lactic acid, so you're not sore. So what we found in a really landmark study down at North Carolina Research Institute is they took a group of bicyclists and they took their blood before, during, and after the event, and they found for the first time in recorded history, there were 43 different metabolites that started providing for the cells to burn before the ride. And within 20 minutes, it made those products called fatty acids. They were burning before the sugars. So adults could burn before sugars. So we're using this hugely in athletics right now to prevent the soreness afterwards. Hormones, on the other side of the question, are produced. Let's take with the most common hormone that people have problems with as adults in America today. What is it? Insulin. Insulin's a hormone. It's supposed to tell the cell, open up and take in sugar so we can burn it in this process. That gets 2 different problems. In type 1 diabetes, they suppose that the cells in your pancreas have lost the ability to do it, or they're dead. Type 2 diabetes, it means that the cells in your body are not recognizing that plug-in signal, and so they don't open up. Thus, you get too much sugar, keeps cruising around through your veins, eventually crystallizes on the side walls, and you start losing the blood flow, and then you start losing limbs. So, in this, that's a hormone that has a function that's a lock and key function. And when that goes bad, it's either the production or the plug-in that goes bad. So we now see that the communication on both ends, either in one case, we now know that we used to think all type 1 diabetics had a nuclear bomb go off in their pancreas and they lost all the aisles of Langerhans cells that make insulin. But we now know that some of them have many, if not all, the cells still remaining. They're just not getting the signal in the right way to make insulin. So those people with a hormone problem, we can sometimes trigger the signal at the production of hormones, and all of a sudden the cells start to take in, and it's like you don't have a problem. So it's really interesting, all the thousands of different areas that we're opening up in how the body can communicate by simply letting the little cells do the work. You know, most of us get really excited about what it'll do cosmetically. It's crazy what we know how to do now. But most of us, if we start losing your mental acuity, get brain fog, you don't have enough energy to get through the day, they don't sound very glamorous, but when you lose it and get it back, it's monumental. Or if you start getting pain or arthritic changes in your joints and you're starting to have those replaced and all that sort of stuff, what if we could put back the ability for the cells to say, hey, wait a second, we're not making it right. We didn't realize it till we got more information, and now we're just going, this is wrong. So that's really what this has come down to, is they came up with a material that you could take orally. In fact, it was most studied material ever at the FDA, 450 toxicity studies, $29 million in 17 years, and they couldn't make it into a drug. Do you know why? Why?
Because it's not toxic. Because
'Cause
there's
you
no
can't call something
rating.
a drug unless it has what's called an LD50. All of you researchers, anybody know what LD50 means?
Lethal dose of 50%.
It means what's the lethal dose on 50% of the population you're going to be using it on. And if something does not have a lethal dose, you can't call it a drug. Did you know that if a person has a pharmacology degree, almost always their diploma does not say pharmacology, it says toxicology? Isn't that interesting? So when this failed to become toxic under such incredible scrutiny, and at that time they were putting it in an IV, then they said, you don't qualify. The price went from $3,200 a quart because they were going to use it as an IV drip. And they were going to use it as an IV drip because it would only last for 25 minutes. It was another problem in the production of it because it would turn back to salt water. And so you couldn't make it and mail it anywhere and make a viable business, but it had such radical stuff it was allowing the body to do. They all stuck with it for years. Finally went bankrupt, and out of the bankruptcy, it was a fascinating turn of events that got it to where it was now stabilized, and this will last for 1.5 years. And you cannot make it harmful. On any tissues, under any circumstances, you can breathe it, you can put it in your eyes. Yes.
What were they researching it for? Like, what was it going to be a treatment for?
Well, the first research part was going to be for sterilizing dental equipment so it wouldn't harm the epithelium when it was killing the bad bacteria. Then they had a number of things. We're not supposed to imply that it has a medical benefit now because they changed it. But there's a place, if you know how to get it. You wouldn't go to Google you would go to Google Scholar or PubMed.gov. And you can find it under a company called, at the time it was called MDI Medical Discoveries Incorporated. And their initial uses of it will flip your shoes off and floss between your toes. I mean, it was nuts. That feel good. So then it came out now as and here's what it basically says it'll do. One study that tries to put an end to all the me jabbering all the time said, we did a study on 35-year-olds and we found that something interesting happened. The cell signaling supplement contains active redox molecules or cellular messengers that affect genetic expression in a positive way. And I went into a whole bunch of stuff. I could have said it in just a sentence, right? Helping to protect, rejuvenate, and keep cells functioning. The CA redox users enjoy all signaling benefits which translate to health at its fundamental and most foundational level. CA redox has been scientifically tested and shown to signal the activation of genetic pathways or affect genes that improve the immune system function, maintain healthy inflammatory response due to physical exercise, support the body's ability to respond to external stressors, help maintain cardiovascular health and support arterial elasticity, improve gut health and digestive enzyme production, and moderate hormone balance and support vitality and wellness. Essentially saying, if you get the instructions right, it already knew how to make a perfect person. And it'll go back to what it already knew how to do. Yeah.
Is it possible to overdose, take too much?
That was the most astounding part of it, is if you took these individual molecules, they have the ability to kill viruses and bacteria. They are incredibly caustic, but they occur every time you breathe and make energy. They occur naturally. So on the one hand, it didn't make sense that you could take these toxic molecules. I'll give you an idea. One of them is, they all occur in pairs when they come off in the cell, but one of them is hydrogen peroxide. Now, you've all used hydrogen peroxide in various different ways, but if you had 100% hydrogen peroxide and you tried to drink 4 ounces of it, you would have your guts in a pool on the floor before you got to the 4th ounce. It is so incredibly toxic and caustic. But without it, you have no life at all. So in its balanced, appropriate comparison with that's called an oxidizer, an extreme oxidizer, and an extreme reducer are made in pairs as you go through that energy production system, and that cell then is always monitoring that. So that's this concept of genetic expression says, how does it read what's happening in the world? How does it read what's happening in the cell? It's using the genes to do it, and it's expressing the genes, and it's expressing multiple genes at the same time. That's the big key factor. Interestingly, these genes, I could show you the study, but these are like observers. And the observer genes in this test on 35-year-olds found that over an 8-week period, there was about a 31% increase in all 5 genes' functions. So they were more aware. And when they turned on, interestingly, each of those genes was in charge of as many as 15 other genes. And when you see the things like sudden crib death gene, oncology gene, everything you can imagine were being turned on at the same time. So across the whole landscape, you were able to monitor and compare things that were foggy 10 minutes ago. And that's how the system is proposed to be working right now, is just to make the genes sensitive enough to know what's happening instantaneously so it can start, stop. One way somebody put it was, if you look, and we started adding, find out that this puts the cell back into a neutral position where it can figure out what's happening and react to it very quickly. And then it says, but if it does that, it's going to ask for certain spare parts and tools to rebuild things, to make hormones, to make it all happen. You must still eat. You must still drink water. You must get sleep. You must exercise. You must get some good loving once in a while. So if you do those things in conjunction with this, it's like all those things are spare parts and tools. Enzymes, hormones, proteins, anything you can take in, what's that stuff? Oils, essential oils, CBD. All of those things have effects, and they have different effects on different people. But if you could coordinate the cells so all of them are back in the center of their universe and know how to do what they're doing, we could now be much more effective with all of them. So they're like spare parts and tools. You're going to build this sanctuary again, and you got it all laying out on the field, and it's not getting built. You're scratching your head. What's missing? What's missing is the coordinator or the contractor that knows what to do with all those parts. So just think how this is going to change the world of nutrition by putting the contractor in that knows what to do.
I'm curious, two things. I wonder, what are the compounds, the different things that are in this that make this, and dosage for different age groups or different?
Okay, well the first one is, I could more quickly tell you the secret recipe for Coca-Cola or Kentucky Fried Chicken. They're called, the compounds that are in it are derived from breaking salt and water into 4 pieces. Anybody know what chemical or what atoms make up salt? Sodium and chloride, right? And then what makes up water?
H2O.
Hydrogen and oxygen. So in the natural process, the cells will break those. That's called, it's used as a catalyst in the Krebs cycle. So you get to trying to break that 6 carbon to a 5 carbon sugar. You can't do that without fire in the cell or a thing called a catalyst. And the catalyst assists it. And with this catalyst in God's creation, which is pretty fascinating, for 8 different steps in that cycle, it's the same catalyst that does a different thing. But that catalyst is salt water, and that salt water can be created into 2 different types of molecules. One of them is called an oxidizer, one of them is called a reducer. Different ones. One could be like the hypochlorous acid. That's a reducer. Maybe the pair to hydrogen peroxide, which is an oxidizer. So it's reducer oxidizer pairs. That's why they call it redox.
Reduction.
And so the redox is like the exhaust that's coming off of this process. And that balance, if it fluctuates or changes, it's working like a binary code like computers. Computers have only a 1 and a 0. What if this is a 2 and a 3, and the next one's a 4 and a 5? It's got 8 different binary codes just in the Krebs cycle off of those binary pairs of reducer oxidizers. And imagine how much computers can do with a 1 and a 0. But if you took 8 different binary codes and interacted them, and God chose that as the language of life, how many options would you have?
You say it's salt or saline, or where do they get it?
Produce it from pure salt and absolutely pure water. That's it. If there was anything else, then they'll run it through electrolysis to break it down. And then there's a process that takes time, centrifugal force, temperature, that allows pieces to be made in specific order so they exist with their opposite, like vinegar and baking soda, but they don't react with each other until biology gets a hold of it. That was the magic that made it last for more than 25 minutes. So it'll make your brain go squish.
So it's like how they process it makes it assimilate into your body and work.
Yep. They put it in a way that can't harm you, which shocks everybody every time they try to study it. Why don't these molecule sets eat you alive? Well, if they did, there would be no life, because they exist because of the Krebs cycle. So we're just replenishing what your body makes anyway, in a way that holds them in a long period of time available, and then biology knows how to reuse it, and it's just fascinating. So it's like the biggest leap in my scientific life by far. It affects everything from a fundamental level on up. You've heard some stories of people and friends that you know, and we have to get this to the world. We chose, well, it was chosen for us that we couldn't go through and become a drug. And as a result, you just have to have caring people working with caring people. Imagine a little boy next door who dumps hot water on his foot, and you can make a difference. Then people talk about it. You have somebody who can't breathe. They inhale this in a nebulizer, and all of a sudden, one guy said, it felt like my lungs were crumpled up paper. And within 3 breaths, I could feel the paper opening back up. Everything changes. Everything changes because it changed for the worse, and it's now just remembering to go back there. Just in our particular family, my wife had severe breathing problems when we started this 10 years ago. 53 years old at the time, 54. She wanted to do triathlons. She was a world-class swimmer when we were younger. We were both swim coaches. But when it came to the run, she sounded like a choo-choo train. She would lock up, her head would go back, veins would stick out, face would turn red, and you could hear her wheezing from 2 blocks away. She'd have to run a block, walk a block, run a block, walk a block. And it was frustrating, but she also got multiple bronchitis over the year, many times pneumonia in a year. Went and got some x-rays. They always said it was pneumonia. Well, it turned out later that she had a lot of scarring from pneumonia as a little baby, and tetracycline and all kinds of problems. Today, 10 years later, she's been using it. If you look at the x-rays, you can see it's a dramatic change in the amount of scarring in her lungs. But she just completed last year, at 65 years old, a full Ironman with a 2.5-mile open water swim, 112-mile bike race, and a 26-mile marathon at the end. At the age of 16, she went in to get her first driver's license, couldn't pass the driver's test without her glasses. Anybody know someone like that?
Myself.
Yeah, I was like, me.
She went in at 64, and she was using it as an eye drop. And she, for the first time at 64, can pass the driver's test without a corrective lenses. So every tissue, every direction. So these 2 ladies have stumbled upon it because somebody in their family was really hurting in a bad way. And that's where a lot of people found out about it. And for me, it was athletics. And what happens when I use it on athletics, one of my people right now is the U.S. Women's Olympic track coach. Is one of the people that I work with. She's one of our distributors now. So there are different ways you can get it, but you must get it through somebody like these who have connections, and you can just order it off the internet, or they can help you get it. It has.
What compounds does it come in?
It comes in this liquid form.
Because you said eye drops, how did you do that?
You take this full strength, you can put it in a bottle, go drop. You can put it in a spray, and you can spray it. You can put it in a nebulizer and breathe it, or you can drink it. You can soak in it. This was all there was 8 years ago.
Yeah.
Then what they did was they found ways to take the same material and put it in a concentrated form for the topical applications, and it makes sense. And you can feel it. If somebody wants to feel it, I'll show you in about 1.5 seconds. You can feel it. Now they've come up with what's it called, a mask?
Yeah. Clay mask.
The clay mask, that's what it's called. Like, this is a clay mask. This is nuts. Where they put it into this, it holds it in place, and you wash it off 10 minutes later. It's like slap yourself. It's crazy how fast your skin will respond to this. In fact, we use this a lot on injuries to focus it. It's just more highly concentrated. So these three are different ways and applications to do that. Once the cells in question find their neutral point where they're going to operate from, then we changed and we started looking at different formulations of nutrients that can cause all kinds of good stuff to happen. One in particular I would recommend to people is this stuff called Mind. It takes some of the hottest things out there that control, or mood, that control your mood. And they're just nutrients that have been known to do that, but we can turn it up dramatically. For me, I cannot go to bed right now without mood, because it will take my dreams and make them happy dreams. And if I don't, I'm worried about everything all night long. The guy I train with, he's another triathlete, 60. He was in the jungles of Panama as a special forces guy, and he got up at our last event, and it was pretty emotional. He said, once they let you go from special forces and you've dealt death and you've taken life and you've been around all kinds of different things, he said, you think you're going to go back to normal? He said, not one of his friends can sleep at night. The fear comes back every night. And he said once he got on that, PTSD and fear was gone immediately if he doesn't use it. And it's just a little sachet, put it in water, shake it up. It tastes great. We can give you some if you want, but that's another piece, and then a whole skincare. But it's all about taking these environments and saying, once the body's getting reoriented to do what it did when you were young, it's just going to need some special help to get there, and that's how they come. So we recommend in dosing, as your question was, with a little kid, they're making lots and lots of this stuff. If they have enough of it, they can build an entire human being in the womb. But we start losing about 1% per year, 10% per decade in our mitochondrial function, and so thus we don't make as much as you get older. So the older you get, the more you need. In my age group, it's going to be predominantly 8 ounces a day of that liquid. And in your age group, it's going to be 4 ounces a day. So there's a sliding scale that goes in between. If you have pathology, you probably use more than that. And so that's how the dosing is handled. It's more age than size. Yeah. Animals, it will work better on animals than it will on people, which is really kind of cool to watch.
Why?
Because it doesn't have a placebo effect.
Oh.
You know why animals don't have a? I mean, we have one chronic, drug for chronic pain that is incredibly effective. It works 60% of the time on people. That's the best they can do. It'll work 100% of the time on animals. You know what the difference is? Animals don't get litigation for pain and suffering. Well, actually, that's the joke. But really, there's so much involved with emotion and pain that we get a lot more emotion than the animals do, and then we perceive pain in a whole bunch of different ways. Thank you for your time. Does anybody have anything that hurts right now?
I don't know. I've got just a pain in my throat. I think maybe from.
With the kids.
Yeah. Try to punch me in the throat. No, just kidding. Just a horrible allergy attack last week, and it just sinuses, sore throat, eyes, nose, everything. Like I've just never experienced that before, and I have this lingering.
Is it to the touch that you feel it? Can you move and make it sore?
I know hurt.
We do this.
Nobody's there.
For some people, they say activate. It can separate. So if you don't shake it up, you could get all water for a while, and then dust for a while. So you shake it up. So then I do want to test one other thing, and that's your reflexes. So I want you to turn your face to me and put your arms out like this. You got flats on? Yeah, good.
Yes.
And then when I go to push up, I want you to just, don't let me push, just stay stable and don't let me push. I want to see if you use reflexes to try to stay up, or if you use a complex to do that. So 3, 2, 1, resist. Feel your toes going up.
Yeah.
Your back arches, both
No
sides.
core strength apparently.
No, you didn't.
Now hold your hands like this.
Okay.
And then when I push down, don't try to lift, just stay stable like
Just
I'm
try to.
jump up on a horse, and don't fall forward. 3, 2, 1, resist.
Sorry.
Do you know why she falls forward? Because she likes me.
You're a good looking guy.
Well, that's what I usually tell people. You want to know this works out, I used to be ugly. Here, so if you put your finger out like this,
Okay.
and apply this just to your neck.
Okay.
And let's see if there's an effect not only on your neck, and that would take a few minutes, but just sometimes it takes a few minutes. But the other stuff, I'm going to test you on those other two things pretty quickly. Now, how much does it smell?
Hardly.
Does it feel oily at all?
No, it doesn't. It feels kind of thin, light.
So it's like, sometimes things just smell too much and
Yeah.
they feel sticky and all that, so it's really nice that this does not. So let's test and see if your reflexes change
Okay. Sorry, I'm
by
a
putting
little.
your arms out front. I've touched it before.
Oh yeah. Okay. Arms
Like
out.
that. Now when I push up, I'm going to ask you to do the same thing. Don't let me push up. 3, 2, 1. So there's the same force. Double. 4 times.
All right.
8 times. You feel your abdominals kick in?
Yeah.
You didn't even lift up your toes.
Did you feel the difference?
I definitely, I mean, I didn't feel the toes going woo immediately. And then I didn't feel I have no core strength. I just had maybe number 6. I have no core strength left. Yeah.
So
I
right
have other
now you
strength,
just
but no core strength.
you're real susceptible to getting back problems when you don't have any core strength. But when your core kicks in, your back's only this big around when you're got no abdominals working. But this much shares all of that pressure and reduces it by like 15 times the force on your spine when everybody else goes to work, and that just happens. So hold your hands like this. And remember that we ask you not to fall forward. 3, 2, 1, resist, don't fall forward.
You don't like him anymore.
No, he was coming to me that time.
Yeah.
Yeah.
Wow. Okay.
I know.
So that is that reflex. This was when it really started to
Take
catch
the
me.
red pill.
Now, what we had one of the nuns do that here. What was her question? Will this work on balance, right?
Yes, yes. Uh-huh.
Can you describe what we did with her?
She
She,
they had her walk with her eyes closed and she was terrified.
Yeah.
And then they put the gel on her and then she walked really well and she felt elated. Like she was so excited.
Oh, really?
Yeah, it was, she like looked like she was gonna cry because she just was so shocked when without her walker or cane.
Oh yeah.
So they tested her with her eyes closed and she couldn't even do it.
So it's really
Yeah.
it's really a communication issue between all the. It takes 130 different muscle contractions to do that.
I believe it.
And it has to come in the right order, and that can get all messed up. You know, that's what it all do. Okay, so any change in your neck?
Actually, well, sorry. Let me swallow for a second. Let me see. Okay, yes. I still feel there's a little twinge that's just, I mean, I've had this sore throat for forever, so there's a little bit in my ear. It does not hurt in this part anymore, which is right where I put the...
So one of the things that's really strange about this is it won't take away pain you should feel. Why is that an advantage?
Because you need to know.
You need to know.
Yeah.
And then there's some that is uncoordinated pain. So that's another interesting study, but when everything starts working together, then somebody doesn't have to overdo. And so you're already starting to feel that. Now you might also have, an infection in your eustachian tube or something, and that affects that discomfort internally, and so it'll still give you a trigger to say, get something taken care of. but it does take away a lot of this stuff that's crazy. Anybody else heard?
Thank you.
You're welcome.
Thank you.
So